Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the self-excited motors, which means the brushed motor and their subtype, self-excited motor and their types, subdivisions. So in earlier videos, we have already covered most of the types of your DC motors. So in this video, we are going to the self-excited motor. This self-excited motor is subdivided into three types. One is your series, second one is your shunt, and third one is your compound. And this compound is further divided into a cumulative and differential, then long and short shunts. So coming up to the self-excited motor, it is a type of motor that the current in the winding is supplied by the machine or through the motor itself. So from the name itself, you can easily able to know that the excitation takes place by the motor itself. So in a self-excited motor, the field winding is linked to the armature winding in a series or a parallel or a partially both are combined together. Then shunt wound or a parallel wound DC motor, the self-excited motors subdivisions, the field winding are connected in parallel to the armature winding and are exposed to the entire terminal voltage in the DC motors. The field winding in the shunt wound motor is linked parallel to the armature winding. So coming up to the characteristics, the shunt motor are normally used in a constant speed operations. The starting torque of the motor is medium, which is limited to nearly 200% by a commutation. Then the speed control of the shunt motor does by decreasing the armature voltage controls. So these are all the main characteristics of your shunt motor. Then coming up to the applications, these are mostly used in your lathe machines. Then for fans and blowers, reciprocating pumps, printing machines, woodworking machines. Then for the centrifugal pumps. So this is the connection diagram of your shunt excited or shunt wound DC motor. Here the field and the armature coils are connected in parallel to the circuit. So that's the reason it is known as the shunt wound motor. Next, coming up to the series excited or series wound DC motor. In here, the entire armature current flows through a field winding as it is connected in a series to the armature winding. So which means it is connected in a series condition. In series wound DC motor, the speed varies with the load, and operation wise, this is the main difference from the shunt wound motor. A series wound motor has a strong starting torque and is frequently used for a high inertia, which means high level of torquing equipments. It's coming up to the characteristics. So the starting torque of this motor is high, which is up to 500% of your speed regulation, and also the speed regulation varies widely with no load condition. This DC motor control can be done by connecting a series resistor method. In this motor, it is essential to connect a motor with the load without, which means before starting of this motor. This is mainly used in your electrical cranes, then electrical trains, then for your trolley cars, conveyor belt drives, electric locomotives, because the this and all can be started with the load, which means normally in a train or even in an accelerator, the load in the sense, the people will be in the equipment or in the machines, or the load is given to the machine, and then only it can be started. So this is the connection diagram of your series excited DC motor. Here the field winding is directly, which means seriously connected with the armature. So this is how the workings takes place. Next, coming up to the compound excited DC motor, it has a series field winding and a parallel winding, which means both are connected to the armature winding in a series and parallel condition. So This motor has a used in your high starting torque equipment and also for a constant speed equipments. So it essentially contains the field winding connected in the both series and parallel connection to the armature winding. So it is mainly used in your most of the industrial applications like rolling mills, then for your conveyor belts and elevators, heavy duty planners, and also cutting machines, because it is having a starting torque high and also the speed of this equipment can be easily controlled. Next, the excitation of this compound motor can be carried out by a two method. One is your cumulative compound and the second one is your differential compound. So in which the cumulative compound, in the sense, the shunt field flux assists the main field flux, which are produced by a main field connecting in a series to the armature winding, which means all of them are connected in a series condition. In here the total flux is equal to series flux plus your shunt flux. The differential compound, in the sense, the arrangement of your shunt and the series winding is such a way that the field flux produced by the shunt winding diminishes the effect by a main series field winding flux. So here the net flux produced in this case is lesser than the original flux, which means your total flux is equal to series flux minus the shunt flux. This is the connection of your compound excited DC motors. In here the field and the which means your main field and the armature field are connected in a series, whereas the armature is connected in a parallel connection. So hence the compound excited motor carries both series and parallel conditions. Next, the subdivisions short shunt and your long shunt. Short shunt, in the sense, if the shunt field winding is only parallel to the armature winding and not the series field winding. So here the shunt is basically an arm that connected in parallel, which means your armature which is connected in your parallel. So it is a short shunt. As you know, the DC shunt motor is used in your devices where speed control is essential. It is mainly used in your centrifugal pumps and other reciprocating type of pumps. This is the connection diagram of your short shunt DC motors. In here the field winding which is connected in a series, and also it is will be act as a parallel to the armature. Next is your long shunt. If the shunt field winding is parallel to both the armature winding and the series field winding, then it is known as the long shunt or simply long wound shunts. This is the example of your long shunt connections. So in here the field winding, both the series field and the main field and the armature field are in a parallel with the connections. So these and all the main highlights of your self excited motor and their types. Hope you understand. I think so. Have a nice day. Nandri vanakkam.